LeetCode problem number 3. Longest substring without repeating characters. Hey everyone, welcome back to the channel. Today we'll be solving LeetCode problem number 3, which is about finding the longest substring without repeating characters in a given string. LeetCode rates this problem as medium, and I'm sure after you solve it, this will seem so easy to you. So let's take a look at the problem statement. We are given a string s, and we just need to find the length of the longest substring without repeating characters. Now, what does that mean? So let's take a look at the first example, which is ABC, ABC, BB. In this case, the output is 3 because the longest substring, which does not repeat any characters, is ABC, which has a length of 3. Now, similarly, in the second example, it's all B's, and the only string that you can get here, which does not repeat any characters, is one character, which is B. So in this case, the answer is 1. In the third example, the string is PWWKEW. In this case, again, we can clearly see WKE is the longest string we can get without repeating any characters. So our goal is to find the length of the longest substring without any repeating characters. And the assumptions are that the string only contains letters, digits, symbols, and spaces. To solve this problem, you need to know some basic programming concepts like loops. And for one of our optimal solutions, you'll need to know how to operate on maps. So let's start simple with a brute force solution. And before we begin with the same force, don't forget to subscribe to the channel and like this video if you like all the algorithms we cover. Okay, so let's talk about the brute force solution. Let's say we were given the string ABC as input. Now for brute force, we'll generate all the possible substrings for this ABC. Now that would mean we fix our start. Let's say we start at A, and then we keep moving our end. So if we start at A and end at A itself, it will give us A as the first substring. Then we move this end pointer to B, which will give us A and B. Then we move it to C, which gives us A, B, and C. Then after that, we'll do similar thing for character B. So we start at B, and this time we'll end at B itself. Please note, we won't end at A, otherwise the string will become BA, which is not in the right order. So starting and ending at B, our next substring is B. Then we move the end to C, so our next substring becomes BC. And next we move our start pointer to C, and in this case we only have one option for the end, which is C itself. So C becomes our substring. So we have 6 substrings from just 3-letter string. And in this case, we can see ABC is the longest substring without any repeating characters. So let's take this up a notch now. So instead of having 3 characters, let's say our string was A, B, and C. Now in this case, our first substring will be just A, then it will be A, then it will be A, B, then it's A, B, and C. Then we start at the second character, which is just A. Then we go A and B. Then we go A, B, and C. Then we go at the third character, which is B. So our next substring becomes B. Then we do B and C. And just to make it a bit more clear, let me try to draw some straight lines. Okay, that worked out. Oh, and then our final substring becomes C, which is right here. Now in this case, it's pretty evident that our longest substring, again, without any repeating characters, is ABC, which is our winner right here. But that's the basic of this algorithm. You just create every single substring possible for the given string, and then check if it has any repeating characters. If it doesn't, then that's your candidate for the longest substring. Okay, so the brute force solution is very simple. We create all possible substrings and check if it has any repeating characters. If it doesn't, then we just check if it's one of the longest string that we've encountered so far. And if it is, well, that's our answer. Here's the pseudocode that you see on your screen. Feel free to pause the video and review this, and then we'll get into the implementation of this. So let's implement the brute force solution. Okay, so here I have my IntelliJ set up with 2 classes, main and solution. Solution is almost a copy of what LeetCode provides. The method name is length of longest substring, takes input as string s, and returns an output int. Similarly here, we have int as the output, length of longest substring, and string s. And right now, I'm just returning 0. Well, let's start implementing our brute force solution. So first we need to start a loop which tracks the start of the string, which is from 0. Then start is smaller than the length of the string, and then we increment start. Now similarly, we need to create a second loop that tracks the end of the string. So in this case, we start our end from the start and we run all the way to the end of the string, and we keep incrementing our end by 1. So now we have our start and end for a string. So to figure out if the substring that we have represented by the start and the end indexes have any repeating characters, there's so many different ways to do it. The simplest way is to create a set, add all the characters from the substring into the set, and if the set is smaller than the size of the string, then it had repeating characters. So for example, if your string was ABC and you put all of these into the set, your set will contain A, B, and C, and the size of the set will be 3, which is equal to the size of the string. Whereas if your string was A, B, C, C, D, then your set will contain A, B, C, and D, which will become of size 4, whereas the string was of size 5. And that's because C has been repeated twice and set only contains unique characters. So let's create a new set which will store characters. Let's call this all chars maybe, and let's make it a new hash set. Let's get our imports in. Perfect. Now let's run another loop which starts from the start that we are tracking, goes all the way to the end. In this case, we are using equality because we want to get the character which is being pointed by the end pointer here. And then we increment loop by 1. And let's add all of these characters into our hash set. So add as start, let's get a character represented by the current loop, and that's it. And I'm sure there are so many other ways to do it. I just wrote something that just came to my mind. Now let's add the if condition that we talked about right here. So that's basically if all chars dot size is equal to the length of the string represented by start and end, which is end minus start plus 1. Now let me quickly explain this part. So let's take an example of the string itself. The index will be 0, 1, 2, 3, and 4. Let's say our start was at 1 and our end was at 3. Then the length of the string is 3. Length will become 3, but 3, which was our end, minus 1 actually becomes 2. So we just need to do another plus 1 to it, which gives us the correct length of the string, which is 3. Okay, so if this condition is true, then that means there were no repeating characters at all. And we need to update our max length that we have seen so far as this new length of the string. And you know what? Let me make this a variable. Final int current length is this, and let me replace this right here. And let's create another variable where we track the max length we have seen so far, which will be int max length as 0 by default, and this is what will return as the output of our method. Now here we get to know that we have a new string with a longer max length. So let's update this. So this should be math.max of the max length we know so far, and this new current length of this new substring that we have found without any repeating characters. Okay, so I have an example here in the main method. Let me run this and see if this works. Perfect, it says correct answers. So it passes with the setup I have, which is very similar to LeetCode. Let's copy our method here and try this on LeetCode. So copying this, going to LeetCode and pasting it right here. So let's run this code first for their base case, and this is accepted. Now let's submit the solution to see if this is really acceptable by LeetCode. And of course not. It says time limit exceeded, which makes sense because look at this last executed input. It's pretty long. I don't even want to click on this view all because I know this is a very, very long string and this brute force approach just doesn't work. Okay, so now it's time to think about an optimal solution to this problem. I'm still in brute force mode, so again, I'm going to ask you to subscribe to my channel if you haven't yet, because there are many more LeetCode problems that we're going to solve, and this is just the beginning. Let's try to brainstorm on an optimal solution. Let's say our input string was A, B, C, A, B, C, B, B. In this case, we can see ABC is our longest substring without any repeating characters, so the answer would have been 3. But how do we arrive at it without implementing brute force? So let's see. At minimum, we have to start a loop that goes through each characters in the string. So we start at A, and then we go to B. Now when we come to B, we somehow need to know if you have seen B before. And the best way to create such a lookup system is using maps. So what if you maintain a map that tracks the characters that we have seen so far and the index of it? So let's first give these characters indexes. So A is at 0, B is at 1, C at 2, A at 3, 4, 5, 6, and 7. Now let's start our iteration. So we are at our first character, which is A, and then we put this in our map, which will say character A seen at index 0. Then we go to B, we look at our hash map if you have seen B before. We haven't, so A and B are our current candidate for the longest substring. And we put this in our map, B at position 1, and we say the max length we have seen so far is 2. Then we go to the next character, which is C. We haven't seen the character C in our map yet, so we add C in the map at position 2. And this time we see our candidate has length of 3, which is actually equal to the size of the map. So we update our max to become 3. Next, we move on to the next letter, which is A. Now when we look at our hash map, we see that A already exists in our map. That means it's a repeating character. So in this case, we have to update our starting position of the substring we have been tracking so far, which will be the last occurrence of A. And we know the last occurrence of A was at index 0 from our map. So our new starting point of the substring starts from index 1. And we don't track the previous A as our current substring, which has no repeating characters. So our new substring becomes B, C, and A. Its length is 3, so there's nothing to update as max length. And we have to update our hash map to update the latest position of A that we have seen, which is 3. Okay, moving on. Now the next character is B. Again, we see that B exists in the map. Its position is at 1. So we update our starting point to be after 1, which is from 2. And we update the index of B in our map to be 4. Now in this case, the length of substring is 3, so we don't have to update our max again. Now moving on, we go to C. Now again, C is in the hash map, the index of which is 2. So we update our start index of the substring to be after 2. So the previous C gets eliminated from our substring, and then we update our hash map to reflect the latest index of C that we have seen, which is at 5. Okay, so now moving on, our next character is B. Now again, B exists in our hash map at position 4. So we update our starting point to be after 4, which becomes from 5. Now this is an interesting case because we have to remove 2 characters now, which is A and B. So every time we update our starting position, we should clear all the characters that we're discarding from our map. In this case, we have A and B, so we should clear its position because we are not tracking A as our current substring. We're not tracking B as our current substring. And then we update our hash map with the latest position of B, which is at 6. And we can actually remove A from the hash map completely because A is now not a part of our new substring that we are tracking. So a new substring becomes C and B, which is smaller than the max length we have seen so far, so there's nothing to update there. Now the next character is B. Now we see that B is in our map. That means we have seen B previously, which is at index 6. So we update our start index of the new substring after 6. And now again, we have C and B as the 2 characters that we need to remove. So remove C from the map, and we also remove B from the map, or rather in this case, we update B to have the latest index we have seen, which is 7 in this case. And let me clean this up as well. So now our new substring is B, its length is 1, so max does not get updated. And now there's no more character to go over, so our answer becomes 3. And if that didn't make sense, let's take another example and hopefully it'll be more clear. So now we have P, W, W, K, E, W as our string. So we start with letter P and we put this in our hash map with the index as 0. Let me populate the indexes on the top. Now the size of the map is 1, so our max length so far is 1. Then we move to W. We haven't seen W in the map, so our substring now becomes P and W, and we put W in the map, and our max now becomes 2. Continuing to the next character, which is W. Now we have seen W in the map before at index 1, so we trim our substring to start after index 1 and eliminate all the previous characters until index 1. So we have P and W that will be removed. And then we update our hash map to track the new index of W that we're tracking, which becomes 2. And let me remove P and W from our string as well. Okay, so now moving on to the next character, which is K. We don't have K in our hash map, so we put K in here. So K has a position of 3. The hash map length is 2, which is the same as our current max, so we won't bother with it. Moving on to the next character, which is E. E is not in hash map, so we'll put E in the hash map with a position of 4. Now this time our hash map's length is 3, so our new max becomes 3 now. Now we move on to W. We see that W is already in our map, so we update our substring after 2, so this becomes our new start index of the substring. Then we remove all the characters prior to this new start index, which is only W in this case. So removing W from our substring and removing W from our map. And in this case again, updating the index of W to 5. Now hash map length is again 3, so the max remains the same. And because this was the last character that we were iterating on, 3 is our answer. Okay, so this is a general summary of the solution that we just discussed. So we'll start by creating a map that tracks the last occurrence of any character. Then we'll track the start and the end of the substring that we have found is the longest. Then we'll start our loop, and that is iterating over the string. And as we iterate, we'll check our map to see if the current character that we are iterating on is repeating, that is, if it's in the map. If it is not in a map, then this might be our new longest string without any repeating characters. But if you already find this character in the map, then we need to update our start index and clear the map based on when this character last occurred. I think this will all make more sense when we actually implement it. So let's get right into it and implement our fancy optimal solution. Let me clean some of this up. I think we'll still need max length, so I'll leave it as it is. So our first step is to run a loop. In this case, I'll call the loop variable as current end index, because this loop is tracking the current character that we are iterating on, which happens to be the last character in the substring, which has no repeating characters. So we'll start from 0, go all the way to the length of the string, and increment this by 1 every time. Let's make a note of the character at the current position. Let's call it current char. It'll be s char at current index. Now in brainstorming, we learned that we'll need a hash map. So let's create that hash map first. Now this hash map will have its key as a character, and it will track the index where we saw this character last in our string. So let's call this last char occurrence and new hash map. Okay, let's do our imports in. Perfect. So as we are iterating through each character, our first step is to check if this map already has this current character. So if last character occurrence contains the key current character, then we have a lot of things to do. Otherwise, we know that this new character is acceptable and we have never seen it before and is a part of our substring without any repeated characters. Now we just need to update our max length in case this is one of the longest substring we have seen so far. So just like brute force time, we'll do math.max on the current max length that we know and the size of the string. In this case, that's the current end index, which was the for loop that we were running. And then we'll need another variable that tracks the start index, I guess. So let's call it maybe current start index, and we'll do +1. And let me just declare this variable up here. So that's int, and we'll start at 0. So with this current start index at 0, when we start our loop, our start and end, they both point at the first character, which is what we want. Now let's get into this if condition if this was true. So if our current character is something that we have seen before in our current substring, then first we need to figure out when was the last index we have seen this character. We can store that at last occurrence, and we can get the value of this from our hash map, which is last char occurrence get the current character. And then we need to update our current start index to be after this last occurrence we have seen of this repeated character. And before we update our current start index, we need to clear everything between the previous start index and this last occurrence from our hash map. So for that, let's run a loop, which is current start index, and we go all the way to the last occurrence. In this case, it should be equal because we want to remove this last occurrence from our hash map as well. And then we increment our loop by 1. And let's update our hash map, last occurrence, and let's remove this key, which is the character at the loop that we are iterating on. Okay, this looks good. And now after all of these checks are performed, let's not forget to put the current character into our hash map. So last occurrence dot put our current character and the index we're at, which is the current end index. Okay, a bunch of things have happened here. So let's quickly recap. So we start a loop which tracks our current end index of our substring. We also declared a new integer which tracks the start index of our current substring. And then we have a hash map that tracks the characters and their corresponding index in the current substring that have no repeated characters. Now as we iterate, we put the current character into this variable here. We conveniently call it current char, so it's readable. Then we look at our hash map to see if this current character is in there, which is done in this if statement right here. If it is not there, then we know that addition of this new current character into a current substring is still a string without any repeated characters. So we try to update our max length in case this new substring is longer than the old one. So we do a simple math max method which takes in the previous max length we knew and the new length of the string, which will be the current end index of the string minus the current start index of the string, and we do a +1 because of the math that we discussed in the brute force solution. But if this current character is actually in the hash map, then we first figure out what the last occurrence of this character was, and we get that from the hash map that we have created by doing last occurrence.get. Then we run a loop from the current start index to the last occurrence of the character we saw, and we remove all of them from our hash map because we are discarding that part of our substring. And then we update our current start index to be last occurrence +1 because we discarded that part of substring, and our new start index is from this last occurrence +1. And then finally, we add the index of the current character that we are working on into our hash map with the right index. And that's all. I know this was not that easy, but I'd suggest doing some dry runs to understand this algorithm if it's not clear. Well, let's run this program and see if it actually works. Okay, it says correct answer for the base question that I set up here. Let's copy this into LeetCode and see if it really works. Fixing some empty lines and copying all of this and updating the code right here. Well, let's hope we don't get time limit exceeded this time. So let's run this code for the base case first. We did the same thing in IntelliJ, and yes, it's accepted. And now the real test. Let's submit this. And yes, this was accepted. I guess that's not one of the best solutions, but still 69% is pretty good. Well, I hope you had fun implementing that solution. And if you did, then don't forget to like this video and to subscribe to the channel and follow me on Twitter. I hope you have enjoyed all the LeetCode problems that we have been solving so far, and there'll be more videos coming out soon. Thank you for joining in. You have a great day ahead.